Hello students.
Hello sir.
Now today we will study about a very important chapter, that is motion. In motion we will study about the concept of rest and motion, we will study about distance, we will study about displacement and a few other things. Now let us find what is this concept of rest and motion. First of all, let's take rest. If a body continues to be at the same place, that means if it is not changing its position with respect to the surrounding, then it is said to be at rest. And if a body changes its position with respect to the surrounding, then it is in motion. You must have thought one way that rest and motion are relative to each other. Relative means related with one another. Let me give you an example first of all, then we will find this out. Let us suppose you and your cousin brother are going to a place and you use the mode of transport of train and you are sitting in front of each other. Now see, the train is moving, you are inside the train, inside your compartment, and you can see one another. For you people, you are at rest because you are not changing your position with respect to the surrounding. But to a person outside, you are in motion because you are changing your position. That's why it is said rest and motion are relative terms. Let me give you another example. Now, it may be the case that Vikram will say that he is sitting and he is at rest. But Vikram, are you seriously at rest?
No sir.
No, but you are at rest. How can you say you are not at rest? I think you are at rest. You are not moving. With respect to the surrounding, you are not moving. So, are you at rest now?
Yes sir.
Now, again one thing. We are on earth. Earth is moving. So, are you in motion? Okay, Vikram is confused. Let me clear the confusion. See, with respect to this surrounding, Vikram is at rest. But if I consider the case of earth in space, Vikram is in motion. So, rest and motion are relative to each other. Now, children, let us move to another interesting topic. For that topic, first of all, let me give you an example. We have, let us suppose an ant. We are having an ant. And this ant covered a distance, or it covered from one place to another, say 2 centimeter to 10 centimeter. What it covered? Yes, Aditya, what it covered the ant from 2 to 10 centimeter?
So it covered a distance.
Distance. So what is this distance? Can you define distance? No? Okay, let me define it. What is distance? It is the total path length between two positions. That is called as distance. Now let us take another interesting term, that is displacement. Now what is this displacement? It is the shortest path length between two positions, that is the initial position and the final position, that is called as displacement. For example, if I have to go from this place to this place, so if I have to give an example, let us see, I have to go from this place to that place. There are two ways. First, I will go like this. Now, I reached here. The second is, I will directly go here. Now see, this one in which I went from this to this place, this is the distance covered. While this one was the shortest path, that is the displacement. Now, before defining distance and displacement and giving you the properties, let me introduce two more terms to you people. The first one is called as scalar quantity. Now, what is a scalar quantity? A physical quantity which depend only on magnitude is called as a scalar quantity, while a physical quantity which depends on both magnitude and direction is called as a vector quantity. Let me give you an example. What is the time between 12 noon to 6 p.m.? You will say 6 hours. Is there any direction required? No. That's why it's a scalar quantity. Let me take another case. You are standing on the highway, there are 4 different paths. You have to go to Jaipur, and let us suppose from this place Jaipur is 200 kilometers away. Will you go to Jaipur if you take any path? No, you need to know the direction. So this is vector. So displacement is a vector quantity, while distance is a scalar quantity. Now children, let's have the properties of distance and displacement. First of all, let's take distance. It is the total path length covered by a body. It can never be 0 or negative. That means it's always positive. The third one, it is a scalar quantity. And the fourth one, that distance, it is unit as meter. The unit of distance is meter. Let us come to displacement. First one, the shortest path length between the initial and final position is called as displacement. It requires magnitude and direction, that's why it is a vector quantity. Third one, it can be positive, negative or 0. You must be wondering, where is this 0 and negative coming? Let me give you an example. You started from this place, take a circular path and came back at the same place. Your initial and final positions are same. So displacement is 0. Now you must be wondering, what is this negative? Let me take this case. You have started from this place, you went to this place, you came back, but you ended at this place. Now this is your final position, this is your initial position, but what is the direction of motion? But your displacement is in this direction, that's why it's negative. And the unit of displacement is meter. Now let us take a few numerical to understand the concept of distance and displacement. The first one, on your screen you can see a triangle. This triangle represents the path. You can see A to B is 3 meter, B to C is 4 meter and A to C is 5 meter. Now what about the distance? Distance is AB plus BC, that is 3 plus 4, 7, total 7. And what about displacement? It is AC, that is 5. I hope you understood the concept of distance and displacement. Let me give you an example and then I will move to the second numerical. The example is that you woke up one fine day, you have to go to school, and the school is at a distance of 5 kilometers from your home. You reach the school. Surprisingly found out the school is closed. You said, wow, that's great. You came back home. Now, what is the distance? 5 plus 5, 10 kilometers. What is the displacement? 0, because you started from home, again reached home. So this was the second case as an example. Now move to the second numerical. In this, what are we doing? Let us take the second numerical. A body completes one revolution in a circle of radius 7 centimeter. Now the question is, what is the distance and displacement of the body after completing one revolution? Now first of all, the displacement, I think everyone knows, the displacement will be 0. Why 0? Because the body started from the same point and ended at the same point. So displacement is 0. What about the distance? In a circle, the distance is equal to the circumference. What is the formula for circumference? Circumference is 2 pi r. So 2 into 22 by 7 into the radius, that is 7 centimeter. So what am I getting? The answer is 44 centimeter. So the distance covered by the body is 44 centimeter while the displacement is 0 centimeter. So children, in this module we studied about scalar and vector quantities, the concept of rest and motion. We also studied about the concept of distance and displacement. What are the properties with distance? What are the properties with displacement? And we understood the concept of distance and displacement better with examples and numericals. Thank you, children. In this module, we studied about rest. A body is said to be at rest if it does not change its position with respect to its surrounding. We studied about motion. A body is said to be in motion if it changes its position with respect to its surrounding. We studied about distance, that is the total path length covered by an object during motion, and we also studied about displacement. It is the shortest distance or path length between the initial and final position of a body. Now, before moving to the next module, you have to answer the following 3 questions correctly. Question number 1. Which of the following is incorrect regarding distance? Option A, it is a scalar quantity. Option B, it can never be negative. Option C, it can never be 0. Or option D, it can be less than displacement. Question number 2. A body completes half revolution in a circle of radius 7 centimeter. What is the displacement covered by the body? Option A, 14 centimeter. Option B, 10 centimeter. Option C, 0 centimeter. Or option D, 7 centimeter. Let's move to the third question. Displacement is a, option A, scalar quantity. Option B, both scalar and vector. Option C, vector quantity. Or option D, none of these.